In this video, we will learn about energy of molecules in the three states of matter. We can relate the three states of matter with the energy of molecules in them. Let us discuss one by one the three states of matter with the energy of movement of molecules in them. First state is solid state. In solid state, the intermolecular spaces are extremely small and the molecules are closely packed. Therefore, molecules cannot have translatory or rotational motion. The molecules can only vibrate to and fro about their respective mean positions, and so energy of movement of molecules in solid state is minimum. Here we have the molecular arrangement in the case of solid. We can observe that molecules are closely packed, because of which there is very small intermolecular space, and due to this reason these particles are unable to perform translatory or rotational motion. Hence they keep on vibrating on the same position, that is their mean position. At low temperature, the amplitude of vibration of molecules is small, and as solid is heated, the vibrational amplitude increases and the kinetic energy of molecule increases. At a certain temperature, called the melting point, the kinetic energy becomes sufficient to overcome the intermolecular force and molecules leave their fixed position, that is, solid is transformed into liquid. So what happens on heating is that these molecules which are vibrating on their mean position gain enough energy so that they vibrate even faster. And when they vibrate faster, their kinetic energy increases and a temperature comes, that is the melting point, where the kinetic energy becomes sufficient enough so that it can overcome this intermolecular force. And once it overcomes this intermolecular force, the molecules leave their fixed position and move somewhere else. Because of this, the solid is transformed into liquid. Moving ahead, let's talk about liquid state. In liquid state, the intermolecular spaces are more as compared to solids, and intermolecular forces are quite weak. As a result, liquid molecules can move freely within the liquid but cannot leave the free surface of the liquid. Thus, kinetic energy of movement of molecule in liquid is greater than that for solid. Now, if we heat the liquid, this kinetic energy of molecule will go on increasing, and as a result, at one point this liquid will get converted into gas. Here we can observe the molecular arrangement in the case of liquid. We can observe that molecules are far apart as compared to the solid state, and hence they are free to move. At a certain temperature, called boiling point, the energy of molecules is sufficient so as to overcome the force of attraction of each other, and as a result, the liquid is transformed into gaseous state. So here, these molecules have some force of attraction between them, but when we keep on supplying heat, or if we increase the temperature till boiling point, these molecules will gain sufficient energy so that they overcome these forces of attraction, and at that point the liquid will get transformed into gaseous state. Moving ahead, let's understand about gases. In gaseous state, the intermolecular spaces are very large and the intermolecular forces are almost zero. Thus, gas molecules can have independent translatory motion in all possible directions throughout the space. Here we have the molecular arrangement in the case of gas. We can observe the molecules of gas. They are far apart from each other. So here we can see that the intermolecular spaces are very large, because of which intermolecular forces are almost negligible. Hence, these molecules can move freely anywhere in the all possible direction. So we can say that kinetic energy of movement of molecules in a gas is maximum as compared to solids and liquids. The translational kinetic energy of gas molecule increases on increasing the temperature of the gas. I hope this topic is clear to you. Thank you.